Okay, welcome to your next lab. This is a fun one. It has to do with pointers, and we're also going to roll our own classes because it's very helpful to understand what's going on when we call a method on an object. Secretly, pointers are involved. Oh man. Are you ready? Let's do this. So there are quite a few files, 6 that you get when you copy all the starter code. Let us take a look at the first few of them. So the first thing that you'll do is rotate. Okay, so you'll use rotate 3 and rotate 3 test. Those files, let's go and look at them. And everybody is following the rules of this header file. So they're using this rotate 3 function that takes 3 pointers to integers. Okay, so this is kind of like the swap function that I explained in class, but fancier. It's like move A to B and B to C. I think it's the other way around. And then like C to A, you get the idea. So it's kind of like swapping, but not quite. And it's using pointers. So your job is to implement the rotate 3 function. Okay, it's going to rotate all the numbers to the right. So okay, I think I was correct. So if x starts out as 42, y starts out as 43, and z starts out as 44, after you call this function with, of course, the addresses, because we're using pointers, then y should become 42. Like x is going into y, and y is going into z, so z becomes 43, and then z goes back into x, so x should now be 44. You see how it's rotating everything? It's like shifting them to the right, and then the z comes back around to be the x. So that is the main job of this function. It shouldn't be too many lines. It's not too bad. But one caveat that you need to watch out for is any of the pointers, they might be null. And if they are, any one of them, x is null, y is null, z is null, or sorry, not x, y, and z, but the pointers themselves, a, b, and c. If any of those are equal to the null pointer, you better stop doing anything because you know how bad it is to dereference the null pointer now, okay? If any of those pointers are null, you should do absolutely nothing at all. Okay, so that's the one thing you need to watch out for. So here's another example. If you have these and you call rotate 3 with x, y, and z, the addresses of those, then x gets moved into y, y gets moved into z, and the old z gets moved into x. Okay, so that is essentially what you're doing. Not too many lines. Just define the function, just some practice with pointers. That's all this is. Okay, so compile as usual. The one thing I've added is this -g now, though, which you know about. It's so that you can use GDB if you accidentally get some errors. So you can go and fix those. It'll tell you what line the runtime error happened on. It's all wonderful. And so I've made some tests for you called rotate 3 tests. It's just one big function with a lot of assert true calls. It's just checking that things are getting rotated properly, okay? Especially with the null pointers involved. So just get those passing and you're good to go. You don't have to write any of your own tests for this part, okay? So all of your work is done in rotate3.cpp for this part. Okay, just get that function going. Now the next thing that you'll be doing is going to take up the bulk of the lab. You're going to create what is called a fake counter class. So we're going to be essentially rolling our own classes. We're going to be using structs and functions to do this. Okay, so I have secretly opened PowerPoint just so that I can draw my office hours PowerPoint. So you remember when we made the counter class? It'd be like counter C, and you can give it like a starting value if you do that in your constructor. And then you can say c.inc, bam. And what this is doing is it's working on some counter object over here called C, and it's secretly got a count inside of it, right? And when you say .inc, it is going into that count and incrementing it, right? It's all coming back to us. So we've made this. Let's figure out how C++ is really doing it under the hood, okay? Because the secret is these methods that we've been calling are really just functions. So maybe if this is in main, if this is all happening in main, here's what the stack looks like, really. Dun dun dun. You have C, which holds the count, and it's got 0 for now, and we're about to call this line inc. Really, there's not an inc method deep down. It's an inc function, and it secretly takes a parameter. It takes, secretly, it takes the address of C. And it's a parameter called this, which is always secretly there inside of every method. And it's pointing to the object that inc is being called on. Okay, So I don't want to draw arrows because that would make it extra confusing because we have pointers going on. But let's say this, the variable called this, is a pointer to the object that the method is being called on. And that's how you can get away with just one inc function sitting around, which is really a method. And that makes it so that you don't mess up when like you call d.inc. You just set this to be a different counter. It's like point over there to counter d. Okay, so secretly inside of the inc method, it's really just a function, and it has a special this variable that's pointing to the object that it's trying to like increment. And when you say count plus plus inside of that method, secretly it's getting translated into this arrow count plus plus. Okay, it's secretly going through this pointer. Now you know. Okay, so what you're going to do is implement this process. We're going to, instead of having a method called inc, we're going to make a function called inc that actually explicitly takes this parameter. And we're going to do what C++ is doing. You're going to have to translate this into this. Okay, that's the idea. So this is happening in counter.h is where this stuff is declared. So let's go there. Bam. So every class now, this counter class is going to be made up of a struct, which holds the count. So every object of type counter is really just a struct. It has no methods. And now all the methods are down here. I encourage you to read all these comments, of course. Now the methods are down here. Here's the constructor for counters. They secretly take the this parameter. You can't reuse the name this in C++. We're going to use self instead. Some languages do that anyway. And so here's the constructor. You can pretend that it only had this parameter, but secretly it's taking this one too, and that's how you're going to implement this. Okay, you're going to make a function that pretends that it's a method. That's the idea. And so here's the inc function on a counter. So we're pretending that this is a method. We're taking self, a pointer to ourself, to the counter that we want to increment, and here's your job inside of the inc function. You have your pointer to some counter with a count inside. You need to turn that counter into, by following the self pointer, an incremented count. Okay? You go inside that count and increment it by 1. That is your job for all of these methods, which are secretly really just functions, right? Constructor to set the starting value into self's count, because self is pointing to a counter. The reset function that's going to take the counter pointed to by self and reset its count to be starting value, and then get count will give back finally the count that is inside of this counter, okay, that self is pointing to. So that is the secret. You're going to implement all of those functions, which are we're pretending are methods. Okay, we're trying to discover exactly how C++ is doing these things. Okay, so instead of classes and methods, you have structs and functions. Okay, that's the idea. And to get a hold of how this is about to work, I've made a bunch of tests. Okay, so counter test has this. So here's how you would use this pseudo kind of class. You'd make a counter, call it C, and then you have to pretend you're C++. You have to call the constructor on counter. It's really just a function now. You give it the address of the counter you want to change, and then the real parameter, and then you call inc, which it doesn't look like this anymore because you have to secretly give the ampersand C. This is it's turning this into this. Let me show you this. This is getting turned into essentially counter inc with the address of C. Okay, that's the idea. Isn't that beautiful? So you're incrementing this counter, you're incrementing this counter again. So now it should be 3 in its count. Then you're resetting that count to 42. It's as if you said C.reset with 42 as the one argument. And then you're incrementing it as if you had said C.inc. Okay? We're doing it ourselves these times. So after this, it should be 42, and one more should increment the count to be 43, and that's what the test is testing. Okay, so hopefully this is making some sense. It's just a bunch of pointers instead of dots and method calls. Pointers and functions instead. So those are the tests. Get those passing. They should help you to understand how these functions are supposed to interact with each other. And yeah, after that, your only job is to add 2 more tests. Okay, so write 2 more tests in this style that's called assert true, and you are out of here. So I guess rotate is to like get you up to speed with all the functions and all the pointer stuff, and then counter stuff, counter.h, .cpp, counter test, those are to really understand what's going on with pointers. Okay, we're gonna do some fancy things with structs as well. Okay, so I think that's all I have for you. Do read these comments. Do yell at me if you have any questions. But yeah, just do rotate, counter stuff, and also counter tests. Okay, that's all. And you'll be turning in your rotate implementation, your counter implementation, and then your extra tests. Yeah, and here's the rubric, and that is officially all I have for you. So please get started early. This is an interesting lab, so I wish you luck, and yeah, as usual, please yell at me if you have any questions. So I will see you later.